All right, so in this update here, what I'm going to be doing is I'm going to be talking about how I have implemented reflection and refraction onto a sphere that has been included into the middle of the skybox. And to do that, I'm going to be taking a look at the GLSL files using the Fresnel strategy. So essentially when we're looking at a vertex shader, what's going to be happening is it's going to be fairly similar to the others. Not much has changed here. The main difference is going to be what happens in our Fresnel frag. So, as per usual, we're going to take a vert normal, take the normal matrix, and then the normals x, y, z, and we're going to multiply those together to get our vertex normal. Then we're going to take our vector 3 vert position, and then we're going to cast it as a vector 3. Um, when we multiply the view matrix, the model matrix, and the vertex together. And then taking our vert direction is, as per usual, we normalize the vertex position, and then our GL position is going to be the projection matrix, the view matrix, the model matrix, and the vertex as per normal. So not much has changed here, but when we actually go into our frag shader, the big difference is going to be that we're going to include the color here. And first of all, we're gonna need to define a vector for reflect, and reflect is going to be, um, excuse me, sorry. So reflect is actually going to be, we're going to take a reflect function and we're going to pass in our vertice or vertex direction and our vertex normal, and then using a vec for the frag color reflect, we're going to take the texture, pass it the skybox and the reflect vectors, and then using the float ratio, that's actually going to compare the difference between the crystal and air itself. We're going to get our ratio of 1 over 1.52, and that's going to determine how much refracts and reflects throughout the sphere that we're going to be using. And then once we do that, we can actually calculate our refraction. Our refract is going to be the direction and the normal, and then we're also going to factor in our ratio as well, so we can get our frag color refract. And then our overall frag color is going to be the mix function of our reflect, our refract, and the dot product of the negative vertex direction and the normal. And then that's going to give us our proper refraction, so that everything's actually flipping upside down. Because as you know, when it reflects, it actually inverts the light waves, so that we perceive things as being upside down. And then when we all implement that, the only main difference there is that in our scene.cpp, I've also included a game object, which is just going to be which is what I'm calling the ball that's in the center of the camera that will move around with the camera. And as per usual, we're going to be taking our pointers, assigning it to it, giving it its texture, and then we're going to be deleting up all the memory and everything. And I have mentioned a lot of this in my previous updates. So for time's sake, I'm actually going to get in and show you exactly what this code can do, as I've described this a lot before. So as you can see, as we boot up, we're getting this image, and you can see that it's actually taking the two buildings from behind as well as this light post, and it's flipping them upside down, but it's also reflecting it off the sides of the angle as well. And as we move this sphere around, it's actually going to be taking, sorry, just trying to get it up right here. It's going to be taking everything and swapping it back so it's upside down. And that's essentially what we were just aiming to do with this, was just get some proper refraction and some reflection through this crystal ball and just kind of look at the world around us while this stays dead center along with the camera as if it's tied to the camera. Thank you guys so much for paying attention to this update. I'll be back with a further one for you.